everyone. I guess some of you might be returning from lunch. Suppose you've had pizza for lunch, and you're at the office, and you have several containers to put this box in. That's a usual issue when you have recycling, landfill, compost, and the like. If you see it, it would go into cardboard. But if you open it, that's a whole different story. That's kind of the question we're having at AWS office in Santiago, Chile, and that's what we're going to present you today. As a colleague, produced a solution for this issue we were having. My name is Gonzalo Vázquez and Rodrigo Monge in the session. This video shows exactly what we have deployed just now in Santiago, Chile. You see, I just pushed the button, there's a camera, took a picture of the plastic bottle and showed you a plastic bottle sign. That signage is exactly what we have at the office. When you see it's a plastic bottle, you push it into the corresponding container. You'll see we have several containers, and that's why we have such questions every day from all Amazonians and all customers that visit our office. A little bit of context within Latin, where we're based. There's huge increase projected in waste by 250. But we have so low recycling metrics that we decided to push this and go farther and improve our Earth ecosystem. Specifically in our country, in Chile, most of the waste ends up in landfills. Only just a few portion of it gets recycled. And we are generating 17 million tons each year. What do we have at our facility? And by the way, it's also in the Venetian Expo, where we've been the whole week showing it for you. It's by the sustainability kiosk. We present an item, whatever you have. That's a banana in the picture. We were usually using for the demo purposes a banana peel or whatever you would like to show, a plastic bottle, the pizza box. You push the color-coded button, the green one over there, and the system analyzes it. What analyzes it? Amazon Nova Pro model running on Bedrock actually does the inference for you and provides output showing you the feedback on screen of the guidance of what kind of signage leads you to the proper container. In average, the solution takes 3 to 5 seconds to show you solution, to show you the result where you should put the waste item. As an exploded kind of diagram, it's very easy, the parts, the button to trigger the photo, a Raspberry Pi inside the 3D printed box. It's a webcam. Any webcam would do. Actually, we do compress the image. We resize it to make it even more efficient in the process. We don't need a full quality camera. And we have a Fire tablet decided to actually show what's going on and what the results are and where to put the item. On the tablet itself, you get the photo that's been taken. You get the image of the classification. Beside it, we're providing extra reference for the user as labels. And below, we're showing you the statistics of what has been going on within the time set that we have specified within that specific setup. We don't only have a pilot at the office, but we actually went to production with this at an event. It's our local version of summits that you might know. We had that at AWS Experience these years. We had 3 recycling sites deployed within the venue, and most of it got properly classified as papers. That was mainly what was available there, without any contamination incident reported from the landlord. This is installed today in Santiago, Chile. Rodrigo will be deploying it in Buenos Aires. The device that's on the demo booth, it's going back to Bogota, Colombia. And we've had some fellow Amazonians that got interested this week. And we might get it deployed in Sao Paulo, Arlington, where our HQ2 is, and the New York office. And even some customers got the idea to deploy it in their venues. Now I'll pass on to Rodrigo, so he'll explain the architecture.
All right. Let's build this architecture step by step. I'll show you how each component appears and connects to the rest of the components to build the complete solution. This solution uses a hybrid architecture. We call it hybrid because we have some components running at the edge like the Raspberry Pi, the webcam, and the bottom and the display where the user sees the waste classification result. And in the cloud, we process the images using AI. Now let's dive into the edge processing layer. We have IoT Greengrass, which is an open source runtime that runs on edge devices. It enables edge devices to process data locally and connect securely with other components and AWS services. And IoT Core, it's designed to help you connect your edge devices with AWS services and other components using MQTT, HTTPS, and LoRaWAN protocols. What components do we have with this solution in IoT Greengrass? We have the webcam to capture the images. Then we have a component nucleus, which is the Greengrass runtime. Think of it as the operating system for the IoT components. It manages the data processing locally and the connection to AWS services. And finally, our Smart Bin component, which contains the custom business logic. Here we have, for example, a Python script to reduce the size of the images for efficient transfer to the cloud. So when someone wants to get an item classified, the person approaches to the station, holds the object in front of a webcam, and presses the button. Then the workflow is triggered. Stream Manager is the one in charge of uploading the image to the cloud. So this component is very critical for reliability as it handles local buffering when the network connectivity is poor, or it does the retries when an upload fails. So once the object, the image is uploaded into Amazon S3, Amazon Event Bridge captures the S3 upload event, and it has a rule to route it to a step functions pipeline. And this service, step functions, is a serverless service to orchestrate the AI workflow. It starts with an AWS Lambda function that preprocesses the image and calls Amazon Bedrock to determine the waste classification type and the confidence score. We are using Amazon Nova Pro, which is a multimodal model that analyzes text and images simultaneously. Let's break down the prompt that it's actually being used at the AWS office. And we had to set the role first. Here we define the AI as an expert in waste classification. We set the expertise level, the context, so the AI understand we are talking about a waste management classification solution and not just a general object detection solution. Then we define the task. The task has a clear step-by-step set of instructions where we analyze the image. We determine the waste classification based on the recycle rules that I'll talk in a bit. Also, it returns a confidence score between 0 and 1, and a structure output using a JSON format. These are the rules, which are particular for your facilities. In this case, that's the AWS office in Chile that has these rules. Here we define, this is like our knowledge base. So we define one category that should match the basket that you have at the facility. So you have to describe like a brief description of each category. For example, in this office, it's not any kind of plastic is recycled, just plastic bottles, for example. So at this point, we determine the result, but we need to store the result somewhere. AWS AppSync provides a GraphQL API layer. This API would store the results into a DynamoDB table and also would enable to query the data for real time. And finally, once it is stored, we need to display the result. That's why we use AWS Amplify, which is a serverless service that provides hosting and deployment capabilities for the web application. The web interface is accessed through a tablet and not only provides the waste classification result, but also has a dashboard with metrics for recycling efficiency at that facility. As you can see, the user experience is seamless. The person approaches the station, push a button, and gets immediate feedback with the waste classification result, so the person could drop the item into the right container. So now let's measure the impact of this solution at the AWS office in Chile.
The goal was not solely to provide an answer for where to put things. It was to actually get our recycling process better and improve our efficiency. Right now, we've been able to achieve nearly 95% accuracy of all types of classifications. So that's pretty nice according to what we previously had, that we had a real mix of waste put into different containers. Cost-wise, the solution in Chile, in other countries might be a little bit different, cost us $350 to put it in place. That's only the hardware setup cost. So it's quite cheap compared to other solutions that we've been seeing around. Regarding usage, every 1,000 images costs $4. As Rodrigo presented, the solution is entirely serverless. So when nothing's going on, there are no costs involved, or nearly no costs, because we have this S3 bucket storage, but it's minimal. And regarding environmental impact, remember we're located the demo in the sustainability kiosk. That's why it's related to this. Our efficiency in recycling within the office has increased 52% with the 6-month evaluation period that we have had. This metrics comes from our landlord. The owner of the building provides monthly metrics for us regarding what the weight of the different type of containers, different type of materials being classified, and that's the metric that they provided to us. And those numbers really matter in terms of environmental impact. Why all this matters to us? We can make it scaling. We were supposed to be scaling to just two offices, Amazonian offices, but since we've been here, already 3 more are interested. As I've said before, even more customers. Rodrigo showed you the prompt. Updating the rules is as easy as changing the last part of the prompt in natural language, depending on what you have on your venues, what you have on your office, or maybe even what you have at home, if you like to do that. Cost effective? Check. Measurable results? Definitely. It's even easier to measure when you have a landlord that actually provides you the metrics, but it can be done. Open source with a question mark? No, it'll be done. We've already started the process to open source it for you. It should be available in the next weeks, hopefully, in GitHub, AWS samples code repos. It should be there. And as I've said before, we are in definition and at a demo. If you'd like to read a little bit more, we have the original blog post, which was in Spanish, but we've translated for you for a wider audience. Then below QR code is an English version. I'll wait a sec. And finally, If you want to learn more about what's going on in the reInvent, what has been announced, and all the services involved during the reInvent, please check out that code. Thank you.